And today we're going to talk about quadratic formula and AGM inequalities, which will be on your quiz. Okay, so my guess is that you have 3 questions. One of them is about quadratic formula, and 2 of them are about inequalities, not necessarily AGM, but inequalities. Okay, so you should know not just the AGM inequality, you should know from basic fact as well. We'll talk about that in a moment, but let's focus on quadratic formula for now. Let's read what's written in the red box. And I want to emphasize something. So quadratic formula, let A, B, C be real numbers. A is not 0. This is quite important. Can someone tell me why is it important? What's going to happen if my A equals to 0? We get a linear, exactly, we have a linear function. We have a linear equation. My next question is, how many solutions do we have for linear equation? One, that's correct. So linear, if you look at the graph, it's a straight line. So it's gonna pass through the x-axis exactly 1 time. So it would have a unique solution. This is why I wanna emphasize this, because you know that for quadratic equation, you can have no like 0, 1, or 2. When do we have 1, it could also be linear equation. So they can set up a trap for you. There are 2 types, not 2 types. I can think of 2 different traps they can set for you just based on A cannot be 0. So I'm gonna write them down. The first thing is they can say, well, let me give you, let's say, find the value of A, values of A in which, let me just give you an equation, ax squared minus 2x minus A plus 2 equals to 0 has a unique solution. Okay, so this is a question I have, and I'm telling you there is a trap here. Why is that? Because if you have this question, you think, oh, quadratic equation, it has 1 solution when the discriminant equals to 0, right? You will say, oh, unique, 1 solution. That means t equals to 0. That is correct. However, when a equals to 0, you would also have a unique solution. So there are 2 different cases. Okay, you should have 2 different cases. One is when a is not 0, you would have a quadratic equation. And this would have 1 solution when b equals to 0. And the second case is when you have a equal to 0, which you would have a linear equation and it has only 1 solution. Okay, so most of the students will miss this one and you will lose mark. So that's a trap they can set for you. Does this make sense? Do we have any question? Okay, I hope I mentioned it. If they give you something like this, you don't fall into the trap. Hopefully you remember I told you A cannot be 0 is quite important. Okay, this is the first thing they can give to you. They can also give you something like this. They tell you, given a quadratic equation, And I'm going to use the same thing. I'm going to use ax squared minus 2x minus a plus 2 equals to 0. So given this quadratic equation, they ask you to determine values of a again. For which values of a such that we have two distinct solutions. Okay, it's quite similar. And now you have a few keywords. One is, well, it's quadratic. Okay, two is it has two distinct solutions. Okay, in this case, you need to consider a, again, to make sure it's quadratic, we need to make sure a cannot be 0. Okay, so you want to say, oh, a cannot be 0. And also what? You want d to be greater than or equal to, greater than 0. Okay, so you have two things you need to consider. A is not 0 for it to be a quadratic equation, and then you need discriminant to be greater than 0. Okay, and this is the one people always miss. Are we clear on this? Do we have any question? Question? Comments? Anything? Feedback, guys, feedback. I can't move on without knowing that you're good. Okay, so this is clear. We will go through those examples. We will not go through those examples. You do them yourself in your own time. I gave you all the main ideas already, okay? So let's look at example 2. Example 1 I did in my last tutorial. So let's look at example 2. Example 2 is a quiz question from last year. And it asks you to prove that for any real d is a constant, it's a real number. Prove that for any real d, the quadratic equation has at least one solution. Okay, that's the question. Now I'll give you 3 minutes to think about it and try it. And after 3 minutes, we'll take it up. I hope you have a copy of the file because we're gonna do 3 minutes. So start now. Make sure you try it because you learn math by doing math, not watching me doing math. So make sure you try it. Okay, time's up. So let's try them. Anyone would like to share how would you approach this question? What do we do first? What are we trying to do? Discriminant, that's correct. What do we want it to be? We want it to be greater than or equal to 0. Exactly. So let's start with proof. We know the discriminant equals to what? What is my discriminant here? I don't want the simplified form, just the original one. What is the discriminant here? We know it's b squared minus 4ac. It's 1 minus 5d squared, that's correct. 1 minus 5d squared minus 4 times 6d squared minus 2d. That is correct. I see. Most of you are correct. Now let's open the bracket. So that's 1 minus 10d plus 25d squared minus 24d squared plus 8d. So that's gonna be d squared minus 2d plus 1. What do I do now? I want to show it's greater than or equal to 0. So what does this equal to? This is d minus 1 squared. That's correct. So this is going to be d minus 1 squared, which is greater than or equal to 0. Okay, this is a base effect. That's correct. That's a base effect. Not greater than 0, greater than or equal to. It's quite important to have the equal sign. Okay, so now we can say, oh, whoops. Now we can say by quadratic formula theorem, by quadratic formula theorem, the quadratic equation has at least one solution if and only if d is greater than or equal to 0. So hence you can say, so my equation would have at least one. Has at least one solution. Okay, so that's the end of the proof. Do we have any question? Well, you can also add here and say, oh, by basic facts, or you don't have to say which one, but you can just say, oh, by basic fact, we know this is true. Okay, do we have any question? Is this clear for you? Okay, people, feedback. Is this clear? And the quiz, do we have to state the base effect we use? I wouldn't deduct mark for you because base effect are something pretty clear. However, if you used something that's a theorem, let's say, for example, the quadratic formula theorem or AGM, if you use them, you should definitely say by AGM, by quadratic formula theorem. Okay, because base effect is something like really trivial. So we don't care about them that much. But if you have anything that has a name, then you should definitely say you used it. For example, AGM or this. Because like think about it, if they have a name, that means they're really important, right? Any other question? That's a great question, by the way. Do we have any other question? Okay, seems like we are good. So I'm gonna, example 1 is leaving for you as homework. Well, you don't have to do it, but I suggest you to do it. And you can find the solution from the recording of my last tutorial, which I'll post it on Quarkus. Okay, so this is for you. We will do AGM now, and we'll do example 4 because 3 I did in my last tutorial. So in this case, we can have as much time as we want for the questions, and we can have a chance to see more questions as well. So AGM inequality. Before we start, there are several things I would like to mention, and they are really, really important. The first thing is, make sure the AGM you memorized is correct, or the AGM you copied down is correct. Every year, we see a lot of students, they got the wrong AGM and they keep using it in their solution. Then we cannot give you any mark because you started from something that's wrong already. Okay, so make sure you have those correctly. That's the first thing that I want to mention. The second thing that I want to mention is, you can see that we have 2 versions of AGM. The second version requires X and Y to be non-positive. Oh, sorry, non-negative. Okay, this condition means that if you want to use this, you should tell us your X and Y are greater than or equal to 0. Okay, otherwise you cannot use them. Does that make sense to you? It's because we have a restriction. It's not like you can use them anytime you want. It's not. Okay, so if you want to use them, you should tell us, oh, my X is greater than or equal to 0, and my Y is also greater than or equal to 0. Okay, so that's the second thing I want to mention. The third thing I want to mention is something people always do and they're wrong. You should not, okay, you should not start with what you need to prove. Do not start with what you need to prove. This is what people do all the time. Okay, what you need to prove is you need to prove it, right? If you start with it, that means, well, there's nothing for you to prove anymore. Okay, so you should never start with what you need to do. And now people will tell me, oh, but my professor did this. They started with what they need to prove. That is called rough work. Okay, for rough work, sometimes for inequality, and this only works for inequality. For inequality, sometimes we start with what we need to prove to give you an idea of how to prove it. But in your formal proof, you should never start with what you need to prove. Okay, you should not copy down your rough work in your formal proof. You will lose mark. What you should start with are base effects or something you know it's true. So what you should start with, you can start with those. You can start with base effect. Okay, any base effects you know. For example, the most common one will be a plus or minus b squared is greater than or equal to 0. This is the most commonly used base effect in inequality. And you can also start with AGM. Okay, either this one or this one. If you have them be positive or non-negative, you can use this one. But those are something you should start with. And this is why I say AGM is not the only way to prove inequality. Don't restrict your mind on AGM only because you just learned it. A lot of the time, they will give you an inequality that's actually starting with a base effect instead of AGM. They might not even give you an AGM question. Okay, so don't think, oh, I just know this, so they must test you on this. That's actually not correct. Okay, so that's what I want to say. That's the third thing I want to remind you of. Another thing, there are many things I want to remind you of. Another thing is, remember, for AGM, equality holds if and only if x equal to y. Why do I want to mention this? Because for some questions, they will ask you to verify it. So you need to check this if the question asked you to. Or, this is quite important to remember, or the question asks you for maximum or minimum value. If they say find the maximum of something something, or find the minimum of something something, you need to check the equality holds. Okay? Otherwise, you will lose mark. You will actually lose mark. You definitely need to check the equality holds. The reason I talked about it in my last tutorial, so check my last tutorial for the reason. This last tutorial. Well, the question asked x equals to y is true and we have to check it. They might ask you something like this. The values of a and b for which the maximum is attained, which is when a equals to b. So what you need to do is you need to find the values of x and y, not just checking if they equal. You need to, oh, this is, okay. It's not check, it should be find values of x and y. Okay, it's not really check because you know this already. It's you need to find the values of x and y. So you would say, oh, the equality holds if x equals to y, so we can let x equals to y and then find the values of x and y. Does that make sense, Vincent? Okay, so again, something related to this, I did it in the last tutorial, and also the quiz from last semester also has something like this. So check that as well. I also did it before, so if you check the file I compiled with lots of questions, there are questions that relate to this as well. So check those, make sure you understand, and we'll do example 4. This is a quiz question from last year, again, last winter. It asks you to prove that for any real x and y, we have this inequality. Again, I'll give you 3 minutes to do this, and then we'll take it up. Okay, for those of you who don't have the question, make sure you write it down, and I'll give you 3 minutes to do this. Okay, really important that you try it out first. All right, and start. We good? I sent the file in the chat, so I'll send it again in case you don't have a copy. So you don't really need to see this page. Okay, make sure you try the question so you really learn by doing math, not watching me doing math. Emphasize this many times, but people keep forgetting. Oh, I see, I see. Yeah, I forgot people want me to print it out. I'll provide another version of tutorial worksheet next time. I'll give you a dark version and print version. How's that? Yeah, it's not that hard for me, so it's okay. Give me two versions. I will post a light version on Quarkus later as well, in case you wanna try them again. Oh, and the file I sent, I'll give you a light version as well. Because that one is in dark background as well. Okay, time's up. So let's try this. Anyone would like to share how you would approach this question? I'm less interested in the answer itself. I'm more interested on your thinking process because that's where people get lost. Seeing the solution itself is not that important, but seeing how we get there, it's much more important. Anyone would like to share? Tell us your observations if you're not there yet. Maybe rough work first? That's a good idea. You can rough work first. But what do we do with it in this case? What's my first step? Yeah, we can do rough work, definitely. So let's write rough work. What do we do first? Anyone? No, nothing? Okay, so I'll tell you my observation and I'll tell you my thinking process. Hopefully it's gonna be helpful for you. So when I see this question, I recognize two things. I have two square adding together. Okay, I have two things square adding together. So now I'm thinking, oh, it's inequality. So it might be AGM, might not be. So I'm gonna write down AGM here. So AGM is xy is less than or equal to x plus y squared. I'm too used to writing this version, but it's actually, you guys know this version. So this is AGM. Observing this, I would say, I don't see it here. Why? Because, well, this would give you two, if you open the bracket, this will give you x squared plus y squared plus 2xy. But you don't have 2xy, you have a minus 2x. So probably not a good idea. But we also have something like x plus y squared is greater than or equal to 0. Two things. Again, your x and y, they are not necessarily x and y, they could be anything. So I'm gonna write as square plus this is greater than or equal to 0. And I'm gonna use circle, square is less or equal to circle plus square to show you they're not just x and y. Okay, so I have something like this, and I'm gonna say, well, for this one, I probably have a greater than 0 if I move this to the other side already. So I'm gonna try that. I'm gonna try to move it to the other side. So 6x squared plus y squared minus 2x plus 6 is greater than 0. And now I'm gonna say I have negative 2x here, okay? I have x squared, I have y squared, but I don't have any term with y, just y squared. So I'm gonna say this y is probably not gonna be touched because, well, we know this is greater than or equal to 0 already. It cannot be combined with anything else, so I'm gonna leave it. I'm gonna try to find something to combine with this, because why? This is also greater than or equal to 0. This is also greater than or equal to 0. So the only thing I'm worried about is this part. Okay? I want to make something with this that's greater than or equal to 0. So what came to my mind is, if I complete a square, maybe we should try to complete the square. Because, well, this is half of the complete the square. What does this need? This needs x squared and 1. Do we have those? We do. You borrow 1 x squared from here. So you would have 5x squared left plus y squared plus 5 is greater than 0. And now this becomes x minus 1 squared plus 5x squared plus y squared plus 5 is greater than 0. This is a base effect. Why? We know that this is greater than 0, this is greater than or equal to 0, this is greater than or equal to 0, and this is also greater than or equal to 0. So this is good. We're done. This is my rough work. Does this make sense to you? Yes, cool. Now I'm gonna write my proof. My proof, I would start with what I ended here. Okay, so we know that by base effect, we have this. That is greater than 0. Okay, and what does this imply? We're gonna open the brackets. So this implies x squared minus 2x plus 1 plus 5x squared plus y squared plus 5 is greater than 0. And you combine the terms. So you have 6x squared minus 2x plus 6 plus y squared is greater than 0. And you move the 6 to the other side, rearrange it, so you'll get what we have. And now you're done. Okay, so this is your proof. Do we have any question? So this question shows you that your quiz might not just be AGM. Okay, so if you're trying to use AGM to prove it, I think you can, but it's gonna make your life complicated. So don't restrict your mind to AGM. Could be anything, could be complete the square, could be AGM. For the AGM question, which is this one, I suggest you to watch the video from my last tutorial. But do we have any question regarding this one? Are we clear before we leave? Clear. The video is already posted? Not yet, because I'm still here. The videos will be processed after I leave this meeting. So not yet, but they will be posted today, probably at 5-ish. Okay, so we'll end here. Again, I can't emphasize enough how much doing questions are important. So really, you should do the questions I left for you, and you should also do the questions here, okay? Do those questions. I will upload a light version for those of you who need to print it out, but it's really important that you do them yourself, okay? Can you explain question 1 again? You got a equals to 0. Question 1? You mean this one? Muhammad? No. Oh, what is?
Goodbye.
Can you repeat that again? I think I heard someone said something, but I only heard half of it.
I gotta go now. Goodbye.
Oh, okay. Goodbye.
See you next time.
See you. Mohammed, which question are you talking about? Oh, this. I just made it up, so I don't know what's the correct answer yet. I haven't tried them yet. Because I just made it up in my tutorial. It's not something formal. So try them and probably compare with the other people. Oh, by the way, we have a Discord. If you want to join, we have a Discord server that has 102 channel, and many TAs and professors are quite active to answer questions there. So I'll leave the link here, and that is the end of our tutorial. Cool. Gonna stop here. And bye everyone.